Assalamualaikum warahmatullahi wabarakatuh. Hi and hello there. A very good morning, afternoon or night to whenever you're watching this. I am Nozlika Akila, who will be your first presenter for today. So, for today, our group will be presenting about volumetric analysis. So, next, I will be introducing our lovely teammates. So, from the left, which is right here, we have Izatul, Suleika, myself, and Farah Azira, and also Fakiha. So, for this presentation, we'll be going through different topics at a time, so we will go through one by one. So, for introduction, volumetric analysis is a quantitative analytical technique used to determine the concentration of an unknown solution through titration. Actually, in this presentation, we are going to talk about acid-base titration because in volumetric analysis, there's like a lot of types. But in this presentation, we'll be talking about acid-base titration, which involves the neutralization reaction between an acid and a base. So actually, in this presentation also, we will be talking about the application of acid-base titration in the skincare industry because it involves a precise measurement of volumes to determine the concentration of a substance in solution, and also for quality control and product formulation. And one of the common substances used in this industry is actually sodium hydroxide, also known as lye, that is frequently used in the skincare industry, particularly in the formulation of soaps and cleanses. It is very essential for the saponification process because it transforms fats and oils into soaps. And also actually by applying this volumetric analysis in this industry, it actually ensures that active ingredients are present in safe and effective amounts, maintaining product stability and consumer safety. Next, I will go to the next slide.
Now, let's look into the theory section, starting with two focus points, which is basic components and types of acid-base titration. Let's break down the basic components one by one. First, titrate is a solution of known concentration that is added to the analyte. Meanwhile, analyte is a solution whose concentration is being determined. Titration curve is a plot of pH versus the volume of titrant added. Next, equivalence point is the point in the titration where the titrant and analyte have reacted completely based on their stoichiometric ratio. Endpoint is the point in the titration where the indicator changes color, indicating the reaction is close to completion. Last but not least, indicator is a substance that changes color when the reaction reaches the endpoint, allowing for easy visual detection. That covers every fundamental term we will rely on. Next, let's compare the two main types of acid-base titration. The first one is direct titration. A direct titration is direct addition of standard titrant to the analyte in the presence of acid-base indicator till the reaction is complete and reaching the equivalent point. Direct titration only involves single-stage titration.
I would like to talk about the methodology used to determine citric acid content in cosmetic products. We prepare all the necessary materials and chemical including burette, stand and clamp, pipette and pipette filler, conical flask, beaker, funnel, measuring cylinder, wash bottle, white dye, lash rod, standardized sodium hydroxide solution, citric acid solution, phenolphthalein indicator, and distilled water. Next, we begin by preparing and standardizing the sodium hydroxide. First, the mass needed to prepare 250 ml 0.1 molar NaOH solution were added. The NaOH solution were prepared. Burette were filled with NaOH solution. 20 ml of HCl were pipetted into 250 ml conical flask. 2 to 3 drops phenolphthalein were added. The HCl were titrated in the conical flask. The NaOH solution from the burette slowly while swirling the flask until endpoint. The color change and endpoint were recorded. The step were repeated 2 to 3 times. The exact molarity of NaOH were recorded and calculated. Next, determination of citric acid in cosmetic product. First, 10 ml of citric acid solution was measured and diluted distilled water up to the 100 ml mark in a volumetric flask. 20 ml of the dilute solution was transferred into 250 ml conical flask, followed by the addition of 2 to 3 drops of phenolphthalein indicator. The solution was then titrated with standardized NaOH burette while gently swirling the conical flask until a faint pink color appeared. The titration was repeated twice to ensure accuracy and obtain comparable reading. The endpoint volume of NaOH was recorded. The pH change was also monitored through the color transition of the pink.
In this slide, I'll be presenting the result of the titration between hydrochloric acid and HCl. As you can see in the table, we performed 3 titration without include the rough. The first titration shows the final blood reading of now which were 19.14. However, the second and the third titration shows the same final blood reading, which is 19.80 ml. From these values, we calculate the average volume of now used to be 19.67 ml. Using this volume, the molarity of the HCl solution was determined to be 1. Next, we have the result of the titration between citric acid and now. Again, we carry out the titration 3 times without include the rough. The now volume used were 24.90 ml, 24.50 ml, and 24.40 ml. For this reading, the average volume of now used is 24.60 ml. This data will be used to calculate the molarity of the citric acid, but in this slide, we are just showing the titration result. Okay, now let's look at example of result of our titration experiment. First, we have the balanced chemical equation between sodium hydroxide and hydrochloric acid. So, sodium hydroxide plus with hydrochloric acid produces to sodium chloride plus water. This is typically neutralization reaction where an acid reacts with a base to form salt and water. Next, we move to the molarity calculation of the NaO solution. As you can see, we're given that the mass of NaO is 1.0 gram. The molar mass of NaO is 40 grams per mole. So, to find the number of moles, we divide 1.0 gram multiplied with 40 gram per mole, we get 0.02 gram mole. Then, we're also given that volume of NaO solution, which is 0.019 liters. To calculate the molarity, we use the formula molarity equals to moles multiplied with volume. So, we plug in the values 0.025 moles divide with 0.019 liters, so we get 1.32 molar, and that gives us the final molarity of the NaO solution, which is 1.32. In this slide, I explain the chemical reaction between citric acid and sodium hydroxide and shows how we calculate the molarity of the diluted citric acid. So for the first one, the balanced equation is C6H8O7 plus with 3 NaO produces to Na3C6H8O7 plus with 3 H2O. So this shows that 1 mole of citric acid reacts with 3 moles of sodium hydroxide. Next, we calculate the molarity of the diluted citric acid. Using the diluted formula, which is M1V1 equals to M2V2, so substituting the values into the formula. So 0.1 molar times with 21.23 ml divide with 20 ml, so we get that 0.106 molar. Then we use that value to find the molarity of 10 ml concentrated citric acid using the same formula, which is M1V1 equals to M2V2. So we get 1.06 molar. In this slide, we're calculating the mass and percentage concentration of citric acid. First, using the formula molarity equals to moles multiplied with volume, we get 0.1 molar times with 0.02 liter equals to 0.002 moles of citric acid. Using the molar mass of citric acid, which is 192 gram per mole, we multiply 0.002 mole times with 192 equals to 0.384 grams. Then, to find of percentage weight over volume, we use mass multiplied with volume times with 100. So we get 1.92%. So the diluted citric acid solution has a concentration of 1.92% over weight.
Back to me, and finally we are going through the final slide. So, in conclusion, volumetric analysis is an essential tool in the skincare industry, allowing for the accurate formulation and quality assurance of cosmetic products. The use of substances like sodium hydroxide shows how chemical techniques are applied beyond the laboratory and into everyday self-care routines. Through careful titration and measurements, skincare companies can deliver reliable olfactory products that meet regulatory standards and consumer expectations. So that's all from us. Thank you for watching.
Thank you, everyone! Thank you, Elmer! Boom!